All right, so we're going to do 4-4C today. And you haven't seen these yet. Jared, you ready? Great. All right, we're going to factor. We're going to factor some special trinomials and binomials. Okay. Now, like I said, all of these can be done using the star method. So if you're comfortable with that and you don't want to know anything else, that's fine. But let me show you the type of problem that we're going to do. Number 1, we're going to take this, x squared plus 8x plus 16. Okay? And that looks like a normal problem from last night, and it kind of is. But there's also a little thing that's special about this. So if you were to do star method, okay, you would put 16 up top, 16 times 1, 8 on the bottom, 1 and 1. And then we get what times what 16 adds up to 8? Do you know? 4 and 4. What happens is you get the exact same thing. X plus 4, x plus 4. Two factors that are exactly the same, which can then be written as, if you multiply two of the same things next to each other, it's just that whole thing squared. Okay? So these are going to be our special cases. And you're like, I'll just do it using star method. And that's fine. Go ahead. But they are going to get a little bit bigger numbers than normal. So here's how you recognize this. This is called a perfect square trinomial. Perfect square trinomials. And they factor as either plus plus or minus minus, the exact same terms. Okay? So this is what it looks like. If you have a squared and your middle term is plus 2ab and your last term is b squared, then what happens with these is they will factor as a plus b times a plus b, which is just a plus b squared. Those are called perfect square trinomials. Here's what you're looking for. You're looking to make sure that the first term is a perfect square. Do you know your perfect squares? When I say perfect squares, do you know what I'm talking about? What's your favorite perfect square? Do you have one?
16.
16.
That's not what I know.
169.
169 is 13 squared. Yes.
36.
What's 11 squared? You know that one?
121.
121. Okay, these are all perfect squares. 144 is 12 squared. Good. 49 is a perfect square. Yes. Okay, so you're looking for those on the outside. Okay? You want your perfect squares to be on the outside, and then you have to then check the middle term. Okay, we're going to check the middle term. So let me give you one that is, let me do this first. You could also have a minus in the middle, but still a plus on the outside. And those are going to factor as a minus b, a minus b. Okay? Perfect square trinomials are going to be exactly the same thing twice. And so it's a minus b squared. All right, so I'll show you one that, you can use star method, but I'm going to tell you, these numbers are going to get pretty large. So here's one. 49x squared plus 42x plus 9. Okay. There's a trinomial, and I have to factor this into two binomials. So I could go over here and go 9 times 49 and then 42 on the bottom of the whole thing, but that's going to take too long. If you recognize that you have a perfect square here and here, they're actually really easy to factor. Yeah.
Oh, 7.
Yeah, 7. Yeah. Okay, so the first one is 49x squared. So what's the square root of that? 7x. The last term is 9. What's the square root of that? 3. The middle term's positive, and so I'm going to get a positive.
Oh, wow.
I know.
I just got that.
Isn't that so good? And then check. Hold on. Check your answer. If I did 7x times 3 is 21x, and I did that twice, that will make 42 in the middle. You want to check that term. Yeah?
Where's 42x in your equation?
I just explained that right there. If you do, see, watch. This is really 7x plus 3 times 7x plus 3. And when we do FOIL, what's the middle part of that? The oi, right?
Yeah.
We can see the first and the last. That's pretty easy. But in the middle, I have a 21x and another 21x.
Oh,
Yeah, it's the middle term. It's where you take the outside and inside and you add them up, and they'll make 42 in the middle. Isn't that a good shortcut?
Yeah.
You love it, is what you do. Number 3. I thought so. How about this one? Did I have a good one? Hold on. I wrote one somewhere on my papers. No, I didn't. Oh, yeah, I did. There it is. All right, try this one. 25x squared minus 20x plus 4. Okay, these perfect square trinomials, sometimes you'll recognize them right away because you're like, oh, yes, there's a perfect square and a perfect square. Okay? If you look at that and you're like, I have to factor this, those numbers are huge. There might be, a shortcut because they are such big numbers. So we're going to factor this as a binomial squared. Yeah. You got it? Yeah.
Okay, so is that going to be 5x minus 1?
Yep. Nope. Almost. 5x minus 2. Yeah. Good job. You fixed your mistake. 5x minus 2. That's it. Easy, right? Do you want to spend time going over here and doing this? 25 times 4 is 100. No. That would take a while, right? But you're going to get that. You will at the end once you reduce and all that stuff. Okay? All right. Now, remember, though, let's try this next one. 100x squared minus 40x plus 4. Now, the thing is, then we get super excited because we know how to do these. But don't get too excited just yet. Don't forget the first rule of factoring. GCF. We need to factor out a 4 first, okay? So you're like, ooh, perfect square, I'm going to do it, just wait. You're getting ahead of yourself. We've got to factor out that 4. All right, so let's factor the 4 to the front, and we get 25x squared minus 10x plus 1. Is 1 a perfect square? It is.
Yes.
Yeah.
Oh, 1.
1 times 1. Yeah. 1's a perfect cube, too. It's a perfect fourth. It's perfect. Okay, here we go. So now we're going to take this and we're going to factor it because we notice we have a perfect square and a perfect square. So my first part's going to factor as 5x. My last one's going to factor as 1. The middle term is minus, and so that's going to be minus. And you can check. You go 5x times 1, and 5x times 1 will give you negative 10x in the middle. Aren't you so good? You try one. Number 5. I didn't give you a chance to answer, did I? Nope, because I'm afraid of what some of you might say.
I mean, we could try all of them.
You could try this one. Oh, let's do a plus. We just did a minus. 8y squared plus 56y plus 98. Now, did you notice that my last term is always positive here? My last term won't be negative. The middle term will change, but the last term will always be positive. All right, so factor out a GCF first, okay? And I'll tell you, I'll go ahead and give you a little hint here. 2 is the GCF, okay? I'll give you a little break there. So go ahead and factor out 2 first and then keep factoring. So I want to see if you can do this one. Let's factor out a 2. So you're left with 5y squared. What's the middle thing here? What's 56 divided by 2? 28, thank you.
Yeah.
28y plus 49. Okay, so those are pretty big numbers, right? But did you recognize perfect square, perfect square? Yes. So keep that 2 out there. The square root of 4y squared is 2y. Square root of 49 is 7. The middle term is positive. There you go. So you get 14y. If you were to check, 14y and 14y make the middle term 21.
I like these.
Me too. Okay, now let me teach you the second one. There's two, yeah. This next one is called the difference of 2 squares. Difference of 2 squares. Okay, so you didn't get any of these last night. Let me show you. Number 6. Suppose I have x squared minus 144. You didn't get those last night. Something with 2 terms like that where you have to factor. Let's say we wanted to do star method on this. Okay? We would, yeah, you can. We would do 1 times negative 144 is negative 144. Yeah, so A is 1, C is negative 144. What's B? 0.
Oh.
Put a 1 here, 1 here. So give me two numbers that multiply to give me negative 144 and add up to 0. Perfect. 12 and negative 12. So this is going to factor as 1x plus 12 and 1x minus 12. These are very special. And do you see why there's no middle term? Foil this out. Just do the OI part. Negative 12x, positive 12x. Gone. Now, note a couple of things. It is the difference, that means subtraction, so addition does not work. The difference of two perfect squares, okay? Let's do another one. Oh, let me show you. So if you have a squared minus b squared, it's always going to factor as a plus b times a minus b. Okay? So my last ones, the perfect square trinomials, were plus plus or minus minus. This is one of each. Don't try and combine it into one. They're separate. All right, so let's do number 7. 4x squared minus 25. Okay? You can choose to do star method if you want to, but then there's a shortcut. Okay? So this is the difference of two perfect squares, so I'm going to need two binomials. One's going to be plus and one's going to be minus. Yeah?
Could it be
Let's see.
2x plus 5?
Yep.
And then 2x minus 5?
Perfect. Exactly. These are my favorite, by the way.
Yeah.
I know. You're getting these. You're doing great. Okay. Don't forget, you do need to factor out the GCF. So if you had something like 25x squared minus 100, you might think, oh, cool, difference of two perfect squares. Now, factor the GCF out first, and then see if you can keep going. So this one, you factor out the 25 and get x squared minus 4. And then you factor again, because x squared minus 4 is the difference of two perfect squares. So that'll be x plus 2 and x minus 2. Can I show you real quick something? Sure. Okay. Let's say that I didn't factor out the GCF, that I didn't see it. I was too excited because I saw perfect squares, and I went like this, and I went 5x minus 10 and 5x plus 10. Now here's the thing. Is this completely factored? No. They share what? A 5. And so what you can do is you can do that. Same thing here. So if you forgot, but then you noticed it here, you get 5 times 5, and you'd get the same answer that I did, just doing it a little bit different. Do you see that?
No. What?
So I factored it to here, right? 5x minus 10 and 5x plus 10. But then I noticed in here that they both have a common factor of 5. So I factored the 5 to here. Same thing with this one. And then, I just combined all my stuff. Okay, you try one. Number 9.
I think say that after like every problem.
Oh, no, I don't.
Or a lot of them. Like you try them and then you like try them.
Yeah, try them. 4x squared minus, see, a perfect square we haven't used yet today. 121y squared. Oh, tricky. Yeah, you got this. Yeah, you think it through. And then I've got the most trickiest one for you ever.
I've got it.
Just do the same thing you've been doing. The difference of two squares. Give yourself two binomials. One's going to have a plus, one's going to have a minus. Square root of 4x squared is 2x. Square root of 121y squared is 11y. Perfect.
Wait. Oh, darn. I did 2xy times 2x minus 11 times 2x plus 11.
You've got the y. Yep, there's
Well,
a y
I
there.
put the y on the outside.
Oh, nope. It goes with it. All right, last one, number 10. This one's a little extra, so yeah, it's pretty good. Here we go. Let's say that you have y to the 4th minus 81. Now, that y to the 4th might scare you a little bit because we haven't, seen anything like that yet. But this is still the difference of two perfect squares. Y to the 4th is y squared times y squared. Do you agree? Yeah. And then what's 81? Plus 9 and minus 9. Okay. Now if you stop there, you've done a pretty good job. Yeah.
If it was y to the ninth.
Y to the ninth? No, it's not a perfect square. Only evens would be a perfect square.
So like y to the sixth.
Yeah, because that would be y cubed times y cubed. Do you remember when you multiply exponents, you add them up? Yeah.
Oh.
I know. Yeah. So you would need an even so that they're the same. Okay, now here's the thing. This right here is done. Okay? People think that that factors as y plus 3 times y plus 3. Those people are wrong, okay? Because that would end up with a 6y in the middle. There's no middle term here. This, however, you can keep going. Okay. So leave this as y squared plus 9. But this over here is the difference. Remember, I mentioned that earlier? The difference of two perfect squares. Is this the difference of two perfect squares? No. It's the sum. And the sum of perfect squares does not factor. Well, excuse me. It doesn't factor in the real world. It factors in the complex world, which we'll get to later on. Second semester. Imaginary numbers. Y minus 3. There you go. And that would be completely factored.
Wait, what?
Mhm.
What do you mean?
Yeah. So this does not factor. No, you cannot factor that. Like, what do you, if you thought that that factored as y plus 3 times y plus 3, because a lot of people do. But if you were to FOIL this out, you'd get the first and last and all that. But check out the middle parts. 3y plus 3y, there's no 6y in there. Okay?
How does
It doesn't factor.
what about the other?
This one is the difference of two perfect squares.
It's
So it's negative. So it's y times y, and then negative 9 is positive 3 times negative 3.
Okay.
Yeah,
I don't understand why you couldn't have left it.
I don't know.
because it's not done yet. You can still factor.
Okay.
Yeah. See, what happens is, like, for example, if you get something like this, 2x squared minus 2x minus 12, okay? And let's say you decide, okay, everything has a 2, and I'm going to factor this, and then you left it and went to the next problem, you would be wrong. You have to factor it until you can't factor anymore.
Okay.
This can keep going just like that last one could keep going. But it's hard to recognize them sometimes. I've always liked this problem, real quick. If you had something like 5x squared plus 500, okay? And I tell you to factor that, and you factor out a 5, and you get x squared plus 100, that's all you can do. I'll have people that want to keep going on that one because they think, oh, I got to keep factoring, keep factoring, keep factoring. But this one is not the difference of two squares. If there's a sum in the middle of two terms like that, it's not factorable. Okay?